In this problem, we're going to work with decibels. Decibels are a great example of a logarithmic model because what we try and do is we try and model sound, which can vary intensely wildly, by using a logarithm. What we do here is we talk about the decibel rating of a sound. You've probably heard something about decibels. Rock concerts are very loud. They're like 100 to 110 to 120 decibels, whereas very soft speech might be as low as 20 decibels. The way you measure decibels is you take the intensity of the sound, I, you divide by the intensity of a benchmark sound, I sub 0, you take the log, and you multiply by 10. So we've got this problem right here. A sound triples in intensity. Find the difference in decibel rating between the new sound and the old sound. Alright, so how do we get this started? Well, a couple of things that we need to talk about is that we're going to let I be the old sound. So 3I is the new sound. Note that we're talking about a difference in decibel rating. So the expression we want to start with is the decibel rating for the new sound and the decibel rating for the old sound with subtraction in the middle. So 10 log of 3I over I sub 0 minus 10 log of I over I sub 0. We want to manipulate this until, believe it or not, we're going to get a number out of this. So, a couple things to note first. It's really tempting to say you have a 10 next to a log, they cancel out. Don't do that. Because unfortunately, the rule we have is that 10 to the log x equals x. Notice that it's a power here. We don't have powers over here, so we can't use the cancellation rule. Very frustrating. Oops. So what are we going to do? Well, first off, let's factor out a 10 from this expression. Alright, I'm going to show you two ways to handle this problem. The first way is the quick way, but it involves a lot of compound fractions, so you may not like it. So let's see how it goes. So what I'm going to do here is I've got my 10 on the outside, and I remember that division between two logarithms subtraction between two logarithms turns into division inside the logarithm. So this expression is equal to log of 3I over I sub 0 divided by I over I sub 0. So notice what just happened there. I took the subtraction between the logarithms and turned that into division. Now you may see a lot of cancellation occurring here, but if you're not quite sure what to do next, here's what we can do. We can write this as 10 log of, when you divide by a fraction, you multiply by the reciprocal. 3I over I sub 0 times I sub 0 over I. And now we can do a ton of cancellation, because notice that the I sub 0 cancels with the I sub 0, the I cancels with the I. So I told you we get down to a number. Here's our number. It is 10 log 3, which is, to 3 decimal places, 0.477. What we just said here is that if you make a sound 3 times more intense, the decibel rating just goes up by about half a decibel. Now I said I'd do this two different ways, so if you don't like this way that I just did, hang on, let's see if another way works better for you. In this second way, what I'm going to do is, instead of combining the logarithms, I'm going to break logarithms apart. So this is log of a quotient. It's going to be the log of the top minus the log of the bottom. So it's log of 3I minus log of I sub 0. Minus, I'm about to subtract some stuff, so use lots of parentheses. Log of I minus log of I sub 0. In parentheses to match that one, in parentheses to match that one. Hey, I can break this into two pieces. This is log of 3 plus log of I minus log of I sub 0. Distribute this minus sign, minus log of I, minus makes a plus, plus log of I sub 0. Woo! We did it, but no nasty compound fractions. Nice things that happen here. Log of I minus log of I. Minus log of I sub 0, log of I sub 0. Yay! We got the exact same thing we got before. 10 times the log of 3, which is 0.477. You can do this problem either way. I prefer to do it the first way with the fractions, but if you do not like fractions, you don't have to use them. Do this. In either case, you're going to be using some of your laws of logarithms, so you want to be comfortable with those before you attempt a problem like this, or at least have them nearby so you have something to look at.